methodology, our system will be using 4 out of 5 wireless sensor network, which will be connected to each other. The first one is terrestrial. This sensor will be used to predict weather and track the environment. Second is the underground wireless sensor network. These sensor nodes are hidden underground that monitor the activities and collecting information of the plant, such as soil temperature, pH level, and more. The gathered information will be sent to the base station of analyzation. Third is underwater wireless sensor network. This sensor will be used to control the flow of water used in delivering water supply or an irrigation system to agriculture crops. This sensor will also use to measure water level and water supply to the plant. Lastly, multimedia wireless sensor network. This sensor consists of tiny sensor nodes that can sense, actuate, compute, and communicate. The drones will be equipped with multimedia sensor that can capture image, video, and audio. The nodes will be spread around the field for monitoring. There are 2 monitoring drones that we will be used: multi-rotor agriculture drone and fixed-wing drone. Multi-rotor agriculture drone will be used for precise image capturing and scanning fields and objects. The good thing about this drone, it is very customization. It's very customizable. It is equipped with GPS. It has expansion base, which will allow you to add components such as camera, sensors, computing board, communication tool, and more to help gather data from a bird's eye view. The second drone will have a fixed wing. This drone can also capture professional grade aerial image and is capable of detecting areas of progress which will take longer of it will be monitored by naked eye. Internet of Things. Implementation. In the proposed system, there are 3 types of layers. The first layer is device layer, then network layer, and lastly the application layer. The device layer consists of devices that can sense, identify, actuate, and give internet access. The data collected by device layer will then be passed to second layer, the network layer. The network layer is the cloud and interface. The connection between devices and user. Data will then be passed to the third and last layer, the application layer. In short, data is being transmitted from sensors to cloud to interfaces to actuators. There are 6 main stages for transferring data from device layer to application layer, which are sensing or perception, storage, communication or transfer, processing, analytical, and actuation and display. It is normal that sensing will be the first step because this is where data are taken by. sensors. Then it will go through steps until information is ready to be sent to actuation device. As mentioned, the device layer consists of the devices that can sense, identify, actuate, and give internet access. The example of this is sensors, which can collect information and transmit the data wireless going to the cloud. This device can also receive commands from the end device to either active or deactive mechanical components. The network layer is also an important part of the process because this layer connects the sensor and the end device. Network layers receive data from wireless technology that can communicate like wireless sensor network. 5G connection will be used since it has higher data rates, can cover large areas, peak throughput is high and higher flexibility than other networks. Application layer. This layer is the most important layer because this layer lets the farmer decide by controlling the devices through internet. Application layer is responsible for storing data sent by device layer that passes through the cloud. This layer also takes care of data analytics by cloud computing and data access using a developed software application. There is an option that data can be stored in the cloud for emergency purpose. Next, conclusion. The Internet of Things system is capable of conserving resources, energy, time, and minimize waste. This system shows that it is also capable handling large-scale farms because of its precise output and easy to monitor the data without wasting time on checking it manually. This system will help farmers by having precise calculation of data from sensors and time efficient to maximize their profit and minimize their loss. Next is recommendation. To improve the security, IPv6 is much better compared to IPv4 because IPv6 contains 128 bits, each which give it a 340 underzillion possible addresses, while IPv4 has 4.3 billion possible addresses. Energy conservation. This system can use to run fully solar power to save more energy. Third and last recommendation is to install an emergency network backup. The emergency network backup will have a great impact on the data security of the farm in case the main network has lost connection to the internet. Routing process will then connect to the backup network. Because the sensor uses wireless network to pass data to each node to the main server of the farm or the farmer.